Here are the solutions to the 2 free response questions I assigned over spring break. Again, you got 5 points for just completing to the best of your ability each problem, but now you can go through, check the solutions, as well as the point values assigned to each part of the problem. So both of these were no calculators. Problem number 1 gives us information about 2 particles moving along the x-axis. We're given the position function of particle P and then the velocity function of particle Q. So just note the notation here used for each function. So it's just V sub Q indicating it's for particle Q and then X sub P. We're also given the initial condition here. Particle Q is at a position of X equals 5 at time T equals 0. So let's go through and look at each part. So for question A, we want to know when the particle P is moving to the left. So we're first going to sort of make a connection of how we know how to find this, which means we know a particle's movement is based on its velocity function. So the first statement here is that P is moving to the left when the velocity of particle P, notice how I have this written here, is going to be negative. So we want to go through and first make that connection. Well, the velocity is the derivative of the position function. So I'm writing this out. And then I went ahead and found the derivative of this. Because the position function is a natural log function, the derivative would now become 1 over this function, or this expression, t squared minus 2t plus 10 times the derivative of that quantity, so 2t minus 2, and you get 1 point for just writing that out, making this entire connection and finding this derivative. Next, we want to figure out where this velocity is equal to 0. We're going to make a number line and test the values here. All right, so what I went ahead and did was I just set VP of t equal to 0, and when a fraction is equal to 0, that means just the numerator has to be 0. So all I did was set 2t minus 2 equal to 0, which gave me t equals 1. So on the number line here, notice how I have it labeled. Numbered it from 0 to 8. Yes, even though this is a closed interval, we're not asked for a max or a min, so I just want to find the sign values here. So I just tested 1/2 and then 2. So when t is 1/2, 2t minus 2 is going to be negative. It turns out that our denominator is always positive for values between 0 and 8. So when t is 1/2, I get a negative divided by a positive, which gives me a negative there. And then for any value between 1 and 8, I chose 2. We'll get a positive value there. So our particle is moving to the left when our velocity is negative. So I could write this out now. Our particle is moving to the left in the interval between 0 and 1, where 0 is included. So we get our second point for this answer. So 2 points for part A. All right, I'm actually going to use the number line that I used in part A. Even if you didn't use it in part A, we would definitely want to redraw it here or construct it here. Here we're asked to find all times t during which the 2 particles travel in the same direction. So I'm actually going to go ahead and make a number line for the velocity of particle q. So again, from 0 to 8. But in order to find my critical numbers here, I need to set that equal to 0. So right below it, v sub q of t equals 0. It's already found for us here. So that is t squared minus 8t plus 15. This can be factored into a t minus 3 and a t minus 5. So the particle q either changes direction or it's at rest at t equals 0 or t equals 5. So I'm going to go ahead and put these 2 values up here. We'll say 3 and 5, and then just test some values here. So I could test a 1, a 4, and then a 6. So between 0 and 3, all of these values are going to be positive if you just substituted that in real quick. At t equals 4, so between 3 and 5, we should be getting a negative value and then positive afterwards. So we're looking for the same signs here. So I'm actually going to go ahead and write that out. So the same direction when Vp of t and Vq of t have the same signs. All right, so Our second problem, we're given a cylindrical barrel, gives us our diameter of 2 feet, and we are given dH over dt, so that's the rate of change of the height of water in the barrel with respect to time. And again, we're given an expression, not just a direct number here. And the unit of measure, H, is measured in feet, and T is measured in seconds. We're also reminded of what the volume of a cylinder formula is. So let's take a look at part A. Again, this is no calculator. We want to find the rate of change of the volume of water in the barrel with respect to time when the height of the water is 4 feet. Again, it reminds us to indicate the units of measure, so you can get an easy point for that or lose a point if you forget that. So right now we want to know what dV over dt is, so this is a related rates problem. So when h equals 4 feet, we are given, so writing out what we know, so we know that dH over dt is equal to negative 1/10 radical h. Again, that's going to be feet per second. So when we go to use the formula for volume, that V is equal to pi r squared h, and we go to differentiate this with respect to time, we do need to use the product rule here. And in doing so, let's say I do this with respect to r first, we're going to get a 2 pi r h times dr over dt plus, then we'll just get a pi r squared times dH over dt. But if you notice here, dr over dt is not mentioned here in the problem, but it's the radius. It does not change in this problem. So we could also write that dr over dt is not changing. So that's equal to 0, which means this whole part just goes away, because in fact our radius is constant. Our radius actually equals 1. So the radius is constant, not a variable. So even when we go to finish this, we could just say if the radius is 1, we get pi times dH over dt, or actually the radius squared is just going to give us 1, so I don't have to write that. But then dH over dt is going to be the negative 1/10 times the square root of h. So now when h equals 4, dV over dt is going to equal pi times negative 1/10 times the square root of 4, which will give us negative 2/10 pi, or negative 1/5 pi, or negative pi over 5. And again, this is volume, so this is going to be cubic feet per second. So we get 2 points for this problem, 1 point for writing out this part here, the dV over dt, and then 1 point for the answer with the units. All right, for part B, when the height of the water is 3 feet, the rate of change of the height of the water, so that's dH over dt with respect to time, is that increasing or decreasing? So to determine if a function is increasing or decreasing, we turn to its derivative. So we actually need to find the second derivative here, or the derivative of the rate of change of height with respect to time. So we first want to find this. So this is going to equal, we'll have negative 1/10, and then it's going to be h to the negative 1/2. And then actually times we'll put the 1/2 in front of it. So negative 1/10 times 1/2 h to the negative 1/2, which really becomes negative 1 over 20 radical h. But then we also need this times dH over dt, because again it's with respect to time. So bringing this back in, we're going to get a negative 1 over 20 radical h times negative 1/10 radical h. The radical h's divide out, and we're actually left with 1 over 200. So knowing this, it's a constant here, so this is positive. So we'll write this out, that since the second derivative here is positive for all h, we'll say just greater than 0, because any negative height doesn't make any sense. dH over dt is increasing then. for all h greater than 0. So this is our final answer here. We are given 2 points for finding that second derivative, and then 1 point for the answer. So 3 points for part B altogether. All right, for C, at time t equals 0 seconds, the height of the water is 5 feet. Use separation of variables to find an expression. So we don't have to find all specific solutions, and you're going to see something happen within the process of solving this. So right away, notice it says use separation of variables. Very important here. You're going to get 1 point right away for doing this. So we're going to start with this dH over dt. And separate the variables here. So we're going to get dH over radical h equals negative 1/10 dt. So you get 1 point right away for this step. Now we're going to take the integral of each side. So I'm going to write this as the integral of h to the negative 1/2 dh, and then just negative 1/10 times the integral dt. So taking the antiderivative here, we're going to get h to the positive 1/2 over 1/2 plus a constant, and a negative 1/10 t plus a second constant. Combine the constants here. I'm going to rewrite this as 2h to the 1/2 equals negative 1/10 t plus a third constant. Divide everything by 2, so we're going to get h, or radical h, we could look at it this way, is going to equal, dividing everything up here by 2 will give me a negative 1/20th t. And then, yes, this will turn to a different constant. So for right now, I'm just going to call overall just a constant here. And then to solve for h is just going to equal this quantity squared. And we are given an initial condition here. At time t equals 0 seconds, the height of the water is 5 feet. So next we're going to use our initial condition and say 5 equals negative 1/20th times 0 plus c squared. So then this just gives me 5 equals c squared. So technically c is going to equal plus or minus radical 5, but we just need an expression. So I'm just going to let it equal positive radical 5. So now h is going to equal the quantity negative 1/20th t plus radical 5 squared. And then that is our solution. This part of the problem is worth 4 points altogether. So right away we get 1 point for separation of variables. You get 2 points for the antiderivative and the constant of integration here. And then our 4th point just comes right from the answer. Now, one thing I do want to point out, you get 0 points for this part if you don't use the separation of variables, but there's no other way to go through this problem. And then a max of 2 out of 4 if you forget the plus c or finding any part of that. All right, so again, I hope you guys look over these in detail a couple of times. Make sure you understand every part, showing all the work here that's necessary, and let me know if you guys have any questions.